Hello again. Today we're verifying properties of quadrilaterals. Couple of things to remember. Parallel lines have equal slopes. Perpendicular lines have negative reciprocal slopes. We've used them in previous lessons and we're going to use them a lot in lessons to come. So the properties of quadrilaterals I would like us to take a look at involve parallelograms, rectangle, rhombuses, squares, and kites. Now, a parallelogram is a quadrilateral that has opposite sides that are parallel and equal in length, and also the opposite angles are equal. So very important things to remember. Now let's think about what does that mean for us in terms of analytic geometry. What does it mean that opposite sides are parallel? Well, we do know that parallel lines have equal slopes. So if we find the slopes of parallel sides, we must prove that slopes are equal for parallel sides. But we also have to prove that the opposite sides are equal in length. So what does that mean? We have to find the length of the lines. Now for a rectangle. A rectangle is a four-sided shape where every angle is a right angle. Same as parallelograms, opposite sides are parallel and of equal length. We have to go back to slopes. Not only that we have to prove that opposite slopes are equal, but we have to prove that adjacent slopes, adjacent means lines that are right next to each other, so adjacent slopes, are how if they're supposed to be perpendicular. Well, I know that perpendicular sides have negative reciprocal slopes. Now, how do we prove that a rectangle is not a square? Because a square has opposite sides that are the same, has 90-degree angles, but I know that in a rectangle only opposite sides have the same lengths. Not all sides have the same lengths. So we must calculate at least two adjacent sides to see if they have the same length or not. So we have to do lengths of lines. Okay. A square has equal sides and every angle is 90 degrees. So we have to find out the slopes to prove that adjacent slopes are negative reciprocals and opposite slopes are equal, but we also have to find the lengths of each side to prove that the lengths are the same, they're equal. A rhombus is another type of quadrilateral in which all sides have equal lengths, so word of caution, that brings us very close to the square. However, the angles are not 90 degree. We know that in a rhombus, all sides are of equal length. However, opposite sides are parallel and opposite angles are equal, like in a parallelogram. So one very important property of a rhombus is that the diagonals of a rhombus bisect each other at right angle. So if we can prove that the diagonals are perpendicular to each other and they bisect each other, which means they have the same midpoint, we can prove it's a parallelogram. So again, we're dealing with slopes, lengths of lines, and potentially midpoint depending on how much information we have. So midpoint of diagonals, depending on how much information a certain word problem provides us with. A kite is a special type of quadrilateral because it has two pairs of sides that are equal. Each pair of sides is made up of adjacent sides that are equal in length. So usually I remember them as the bottom two and the top two. Now very careful with the angles. The angles are equal only where the pairs meet. Where do the pairs meet? Well, at the corners, the side corners where you make the transition from a smaller side to a larger side. So this angle and this angle are equal. Another important property for a kite is that the diagonals intersect each other at 90 degrees. So one of the diagonals, the longer one, bisects the other one or cuts it in half. So the longer diagonal bisects the shorter diagonal, in this case, into two equal halves, and they also intersect each other at 90 degrees. Very, very important properties in the kite. A bit harder to prove because you have to keep track of all these properties. As usual, I am not asking you to memorize properties. I'm asking you to understand. And one way to understand is understanding the relationships between parallelograms, rhombuses, squares, and rectangles. So please remember that any square, any rectangle, and any rhombus is a parallelogram. However, a kite is not a parallelogram. It's just a quadrilateral. Let's take a look at a first example. We have to verify that a quadrilateral formed by vertices A, B, C, and D forms a parallelogram. I'm asking you to sketch these points to make sure that your teacher gave you the points in proper order. Sometimes, even in the textbook, you'll notice mistakes where they say they put the points A, B, C, D on paper, but actually on a graph they are A, B, D, C in the order of the graph. And you have to be very careful because that changes your geometric shape. Two pairs of parallel sides and of equal sides. So first, I would say we have to prove that slopes of opposite sides, so of AB and CD, are equal, and of AD and BC are equal. That would be the first step. Second of all, in a parallelogram, we know that the opposite sides are equal in length. So we have to prove that AD equals to BC and that AB as line segments and that AB equals to line segment CD. And since you have the coordinates of each point, please use for the slope the formula delta y over delta x, and for length of a line, if you remember from a few days ago, the length of a line formula is square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, there will be quite a bit of work involved, and I can't wait for you to tell me in class if you discovered if this particular shape is a parallelogram or not. In the next example, we have to verify that quadrilateral PQRS is a rectangle. We have to prove that it is a rectangle. Same thing, check that the points that are given to you are in the proper order on the graph. Now, let's think about what does it mean for something to be a rectangle. If I'm assuming, P, Q, R, S. I'm going to assume that they are in the proper order. Let's think about what it means for a shape, a parallelogram, or a quadrilateral to be a rectangle. Well, we do know that opposite sides are parallel, so I do know that PQ should be parallel to RS, and that PS as a line segment should be parallel to QR. Also, in a rectangle, I know that PQ should be perpendicular on QR, and let's do at least one more, and QR should be perpendicular on SR. And obviously going on, SR perpendicular on PS and PS perpendicular on PQ. How in a rectangle, I know that we have two pairs of opposite sides that are at the same length, so we must prove that PS as a line segment is equal to QR, and that PQ as a line segment is equal to SR. as you can see, you have quite a bit of work to do. Now, what does it mean for sides to be parallel? We know slopes must be the same. What does it mean for sides to be perpendicular? Well, slopes must be negative reciprocal. Again, quite a bit of work to do. Good luck, and I can't wait for you to tell me in class if you've discovered if this is a rectangle or not. And last but not least, the last one is verifying a rhombus. And what I want you to start with when you're going to start verifying that this particular quadrilateral is a rhombus, I want you to go through the same kind of thinking that we did in the previous two examples and write down what you have to do. Keeping yourself on track and writing down what are the things that you have to prove in order to prove that the quadrilateral is a rhombus will keep you on track, will keep you organized. If you, let's say, make a mistake, it will be easier for you to track that mistake if you know the steps that you have to take on. Good luck, and let me know how it goes in class.